Today I'm going to clarify when you can use which formula in Physics 20 when you're asked spring or pendulum problems. So if you're doing your final exam review, I'm going to incorporate all the formulas that is used for spring and pendulum in the course to clarify what's what. Okay, we'll start with the spring. So we know the basic thing. It's called Hooke's law. So force is proportional to the amount of displacement and the spring constant. So there's a basic, but and then later you learn about restoring force, which is pretty much the same concept, except they play in the idea of the vectors in here. So you start to get these vectors here. So you could, depending on what you're asked, you could be using this formula just by force equals kx, or you could be using the vectors, but it's pretty simple to figure out. And if it's a vertical spring, the only difference is you expand force into mass times acceleration or mass times gravity, because gravity is acceleration, so they're pretty much the same thing. Okay, to continue. The next formula we have is potential energy of a spring is not mgh, unlike all other potential energy, but in a spring it is force times distance, which is given by x, but you have to half it, because we know that the graph of a spring, if you if you compare force and displacement, it's going to give you a slope. So then what you're calculating is the stuff under the slope. So to do that, you have to use a half here. So then you got force times distance and half it. And then of course, sometimes you can open this force into kx. So what you also end up having is, if you put kx into F, you will also have this. So they're the same concept, they're the same thing, just came from the last equation. Next, we know that if you're asked about the period of a spring, it is highly likely that you're going to use this equation on your formula sheet. And that's pretty simple. And if you're asked the mass of an object on the spring, it's likely you'll use this third equation as well. Now the other one that you get is, they talk about the maximum speed of a spring. The maximum speed of a spring is this, and I'll show you where it came from. Amplitude is the same idea as displacement, except it's a maximum displacement where you initially stretch it. So I'll show you where this last equation came from. Okay, so this is where it came from. They equated potential energy of a spring with the kinetic energy of a spring. And we know for potential energy of a spring, it's going to be, let's say kx here. And kinetic energy. And we'll isolate for the maximum speed. Okay, now the only difference, it looks the same already, but just one thing that is different is the x here. The x here, we're going to call it the maximum displacement, so that's going to end up being amplitude. And since if you're going to square an amplitude in here and then square root it, you might as well just not touch it, because if you square it and then square root it, you'll just get the amplitude. So if x or a were 5, I square 5, and I square root 5, you're still going to get whatever you get. Still going to get 5. So I'm going to drag that out here. I'm going to rewrite it as amplitude. And that's where the maximum speed equation came from. So if you're asked to show your work, you can derive it like that. So that's pretty much the most part of the formulas that you need for spring and Physics 20. It's these 4. Now we'll jump to a pendulum, which I think is a little simpler. The pendulum, we know that if you're asked the period, this is the grand equation that you will use. Okay. Now sometimes you might be asked about the force of gravity on this planet, the force of gravity on the mountain, or what have you, and you'll be given things, and then the only thing with that is the equation looks like this, but it's the same thing as the first equation. It's just rearranged. It looks really different, but it's the same thing. If you isolate gravity here, you get this. So that's pretty much all the equations that you need in Physics 20 to answer any spring problems and pendulum problems. For pendulums, there are questions with mechanical energy, but that will be another video.